Hi, today we're going to talk about a EMCA servo controller from Festo. It's a CANopen version, and we're going to connect this to a CECC-LK PLC, another one from Festo, and I'm going to show you how to get this up and running as quickly as possible. So this is the layout right here. We've got our PLC over on the left here, and we've got the drive on the right. It's an optimized motion series drive, so it's got the motor and the controller all built into one. It's node 2 on the CAN network, and let's go get this done. So I've got a project that I've finished already here, which you'll see that is in the video link below the video. And let me just close a couple things here. Okay, so the first thing you need to do is download the latest FCT software for the drive, for the controller. And you need to download the firmware as well. So if you go to www.festo.com, when you get to the website for your country, which is, I'm selecting Canada at this point, you click on the support downloads, come in here, type in EMCA, you'll get a drop down. This is my version that I have hooked up right here. And now you have the tabs. This is the technical documentation. This area here is where you find all your literature. You've got this document here, which is the most important one. It tells you about the profile that communicates between the drive and the motor controller, or the PLC. You download that manual, and then there's installation, wiring diagrams, things like that. Right now I'm going to talk about the software version. And like most of the Festo drives, there are function blocks for the available PLCs. So we're using the CoDeSys PLC, so there's this library right here, function block library. You'll download that. When you go to download it, it's a zip file. When you get that, I'll show you in a minute how to deal with that. The firmware for the CANopen version is this one right here, this 11028. So you would download the firmware, and the Festo Configuration Tool, this one right here. You download that and install that. So you've downloaded and installed the plugin tool, and you've installed it. So now you start a new project. The new project, I'll start a new project, and I'll come back to this one here. So you're in the new project. You don't have any projects at all. You just installed the software the first time ever. You come up to the screen here, you say new project. So you type in a name, blah, 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 author. And now I have many plugins installed. You've only installed the EMC plugin. You can have further. You select the EMCA, give the access a name, pick the version. You always pick the latest. Hit OK. It's going to create a dummy shell. Okay. Now, everything in this software that I use is next or previous, because the way the Festo software works is everything's left to right. So you create a new drive configuration. So at this point, the purpose of this is you're going to create a configuration of what physical hardware you've purchased. So in my version, I have this exact one, 61 TM. I've got a TM-CO, so TM multi-turn encoder, and that's it. If you have a linear axis, you select it, so on and so forth. So at this point, I'm going to just cancel this, and I'm going to delete this and close it. And now we're going to go to my project, okay? So, wrong project, so wrong one. Where is my project? Oh, this one here. Okay. So I have configured the EMCA-CO, And I've said that it's attached to an EGC, this mounting kit, so on and so forth. You can always view it again. Give it a second to open this up. Next. Next. And then that's what you get. So come into here. I always say I have record sequence enabled, and I have some comparators in case you want to use some of these features in the record table. You put a load in. That's the most important thing for tuning purposes, because the tuning starts off based on the load or the massive you selected. The limitations that you see previously here, like this and whatnot, are based upon the combination of the axis and the motor controller. This particular case, I'm just homing to current position. You have a couple other options. Block just means it's going to home against the mechanical stop one way or the other. If you had selected a homing switch, then you would have different options under homing, but you did not, so I didn't. The axis limitations are right here. Feed constant. This right here would be blank. I've already gone online once, so it save this offline. IP address. Okay, so this is default settings here. I've optimized this myself because I was really using a rogue system. Fieldbus. Maximum baud rate I want. The node number I want is 2, and I want FHPP, not CIA 402, because we're using the simple factor group. The default is to have the control area, which is called FHPP, and then the parameter channel, which is called FPC. So FHPP plus FPC. Okay. Next. Direct mode, these values are used, which I'll talk about later. And you put a couple things in for records. I have a record populated up to record number 8. Some messages, things like that. Okay. So you would download that. You can, when you go online for the first time, it should say, hey, access is not initialized. You would download it and it'll store. And from then on, if you make changes to the project and you do a download over here on the right, so you do a download, you say yes. Notice in the bottom left-hand corner, it just turns the FCT checkbox on, say yes. And it took it from your PC, put it on the volatile memory on the controller. The next thing you want to do is do a store. That way it puts it in the EEPROM so that when you cycle power, the information you've changed is still there. So now you're ready to commission. You've come down here, you turn the enable on, you've got the STO, so on and so forth. So here's the STO contacts right here, they're green. And we're ready to rock and roll. So we can look at the status right here. First thing we would do is home it. Click on home, that's good. Now I can manually move it one way or the other. Press and hold the buttons. This single step here is doing individual moves of this size. So if I type in 100, it'll go to 104.77. So it's a relative move. And if I go the other way, it goes back 100 millimeters. This over here on the right-hand side is used to run through a sequence of these ones here. But that's not the point of this video. So we have everything configured. The controller has been set up. The field bus is set for 16 bytes in, 16 bytes out. We're not using this extra area here, which you would use by setting up this here. We're not using that at all. And we can monitor this right here. So the next step is to make sure that we have the latest firmware. So the firmware in this case, what do I have for firmware? Where did I put it here? Homing controller, right here. So this is the latest firmware. If that's not the latest firmware you have, then put the latest firmware in. Again, it was at the website. To do firmware downloads, you simply come into here, you select the file you want, and then you hit the next button and it'll download the firmware. So firmware is up to date. FCT project here has been downloaded and then stored, and you can commission and use the drive. So now you're ready to move into the PLC stage. The PLC stage, as we discussed. So on the website that we were on, we needed you to download the blocks. So you've downloaded these blocks right here. So you create a project from scratch. So I'll leave this open here, this project, which is my completed project, but I'm just going to show you some real quick steps. I'm using CoDeSys version 3.5.7.2. Okay. I'm going to start up the CoDeSys. And it starts up empty. So you come up to here, you select new project. Well, I guess you need the other things here. So we're using a CECC project. Well, you need to have the package installed. So if we go back to the website here, it's going to have another tab here. We'll go to the US website this time, same thing. Type in CECC-LK, hit enter, and just like on the EMCA, there's a software tab, and we want to make sure that we have a couple things. So there is, where is it here? Target support package. This right here. Okay, so this target support package, download this, 3.5.7.1.5.9. And when you go into the CoDeSys and you start it up, go to Package Manager. I already have all these installed. There's 3.5.1.7.9. But if you didn't, you would simply say, hey, install this. You'll select the package. I'm not going to do this, but you basically select it and say okay, open, and it'll install the package here. Okay, so now you've done that. There's another step to take here. Okay, so click on new program, and now you're going to have the ability to select CEC project. I'm just going to say delete me for later. Click on that, hit OK. Now we are communicating CANopen, so I'm going to select the CANopen Manager because we're going to need that in our project. You might want to IO-Link master as well in there. The CECC-LK's got a couple masters on there as well as a device. And you can select your PLC type. In this case, I have the LK. Click on OK. It'll create a dummy shell. So right off the bat, you've got the CAN. You come into here, the first thing you want to do, double click on CAN bus, and we're going to select the 1 megabaud to match the, where is it here? To match the 1 kilobit per second, which is 1 megabit per second. Okay, so we've done that now. Go to the CANopen Manager. I didn't need to do anything else there. The next thing to do is to go back to the website, and you want the EMCA, and you want the CANopen EDS files. This one right there. So click on that, you download it. And likewise, when you did the support package, you will come up to the device repository. You will click on install. You will select the device and say open, and it will install that. So now it's installed. You right click on this, you say add device. You get a list of available devices. You can come up to here and type in EMCA, hit the enter button. That's not what I wanted to do. Delete that. I want EMCA. Why is it not finding this? EMCA. Maybe it's not called EMCA. Bear with me here a second. Here, you have to be, sorry. You have to select, if you're on the IO link and you add device, you can move things around. Here, I forgot about that's what's going on here. So if I come over here, it's going to show me only IO link devices. I come over here, it's going to show me CANopen devices. So just scroll down to where you see EMCA, and what I just installed was version 1.1. Well, that's actually 1.6 is the file version. So you say add device, and now it just added this device. Close. So in here, you come into here, and you're going to put a 2 because we want to match the node ID here, because that's what we're talking to. And you have to configure the PDOs. And the PDOs are basically saying, hey, match me or mate me with what you have right here in the thing here. So we are using the first 2 sets of 8 bytes. So to match that, you turn off these other ones right here. So now we just have FHPP area and FPC. Same thing with reading and writing. Okay, hit the save button, and we're off and running. So at this point, I could simply download the project and start collecting data. Let's just do that for the heck of it. So double click. This is my device. Hit save. I'm going to log into the device. Say yes. I'm going to overwrite everything that's there. Go online, F5, and see how I have everything green here? Everything's all good. And if I come down here to my CANopen mapping, one thing I like to do. I'm just going to go offline real quick here. So under device, under PLC settings, I like to turn these 2 features on. The enable 2, it means update the variables all the time. So if you don't have any code acting on any of these variables, unless you do that, this won't be updated. So by doing this, what I just did there in the device, by doing this enable 2 always in bus cycle time, the variables will always be updated that are in this IO map and even in stop. So if we come back to here, dump that in again, yes. Okay, hit F5 or, hit this right here. One of the 2, F5, now it's running. And see here, we've got some data. Okay, so the SCON. And the SCON is right here. So I'm going to show you something. The FCT software will get kicked off whenever you do a download, because it's basically resetting the controller, and therefore it's shutting off, right? So I'm going to go online now, and we'll see here. So SCON is the first byte, and the SCON bit 4 is on. So this vload is a match to this right here. This one that's true. And if I go to the SPOS, see the SCON is right here and the SPOS over here. So I get SPOS now. So the third bit, which is 1, 2, 3, is on, the MC, and the last bit, which is the referenced. So we are communicating right now, and if I come into here and go, I'm going to come in here and say that's true. Come up to debug, say, okay, write the values. See, I just turned the first bit on, now the enable's on over here. So we're communicating, everything's good. So that's how easy it is to get everything up and running initially. Very simple. So I'm going to take this project offline now and delete it, okay, because I don't need it anymore. I'm going to go back to my project where I've added some extra code. Okay, one thing I forgot to mention, the fact that we had communications working is, hey, how do you wire communications? So I've just got this little document right here. This is all in the user manuals of the Festo product. So you've got the top picture is a picture of the CECC-LK CANopen port, and then the bottom picture here. In fact, the bottom here, item number 1 is the incoming line. I've highlighted the wrong one here. I should have highlighted the one at the bottom, but it's basically it's an M12 type A port, and I've also got a terminating resistor turned on the top. Again, this is all in the user manual, but basically this is the wiring that I used. Works perfectly fine to go between the controller CANopen interface, which is to go from this port right here all the way over to this port right here. Okay, so I'm going to close that. All right, so as I said before, the EMCA has a function block library for CoDeSys, this one right here. So you've downloaded that already, and you have gone to the library repository and you have clicked on install. You clicked it and said, hey, open it or install it, and you've installed it. Okay, so now when you're in the library manager and you come up to say, hey, add library, you come up to here and you type in, Festo _ motion. You would select this one. I prefer to go to the advanced. The advanced lets me see the versions. So this one right here is the one I want. And then if you say OK, it brings it in, this library right here. And you can see that there are function blocks that are available to be used throughout your program and so on and so forth. Okay, so close that. All right, so the library comes with a user manual. I am not going to take you through every little detail because that would be tedious for you, I'm sure. My voice is only so tolerable, I'm assuming. But basically, to get the project up and running with the bare minimum, just to do some moves, you need 3 function blocks. Again, this is a CANopen version, so we're using the FML read. That's reading data from the controller, and then you need FML write. Just like you see in my scan here, the read is first, item 0 or order 0, and the last thing in this routine here is the write. So you read all the data first, do all the processing between it, then do the write. If you read the manuals, that's how Festo wants it done, and that's how you need to do it. Otherwise, you'll run into something of a problem. It's not recommended to do it otherwise. And then the third block is this one block right here, this control block, because this enables you to stop, start, set position targets, so on and so forth. Now, in my case, if you read the manual, so I'm just going to pause the video real quick and go get the manual. Okay, so here's my unzipped version of the library. Within the library, there's a documentation directory, English. Open this baby up here, and Let's zoom in here. Okay, so if you look at the FML read, where is it here? FML read talks about so many different times. Basically for CANopen passing the input data. It talks about this specifically, talks about how things are going to work, shows you the FHPP and FPCN. It's a very nice document. It talks about this stuff up front as far as configuring everything as well. So this document is a must read for you users, and you're going to get my short version of it. So I have an EMCA connected. This right here, I've got a global variable list. The global variable list has, I've basically added tags to reference the various function blocks or POUs that are available. And this data structure, this FMLRef, is the same thing used on every block. Okay, they're all the same. That's because the read data takes information from the controller, shoves it into the input side of this data ref. The bottom here, the write data takes the data from the program, puts it in this data ref. So the data ref is being read and written to from the external I/O. The data is now being populated into here and coming in and populated into the tags and so on and so forth. So you've got these set up. The next step is to add an HMI. The library itself comes with blocks that are HMI coordinated as well. So if you look at the library manager, you'll see there's a visu, and you'll see that there's individual controls, if you want to call them that, visualization controls for each of the blocks that I'm going to use. Okay, so on the HMI, to do that, come in the toolbox. I know this one's called FHPP control, so I would simply come in here, FHPP, and then you take this, you drag it. I'll delete it after the fact. It prompts you for this. This doesn't always work. I don't know if it's a bug in the version of the software, but basically you come up to here, come over to here, and you basically point to the block you're using. So in my case, the block name is X-axis control FB. That's within the right here. So that's this X-axis control. So this is in the global variable list. So if you're on the HMI tab, you click over here. If you want to go look for that, you basically click on this little tab over here. Let me just drag this so you see. There is a button there. So you click over here. You would go to the global variable list and find that one right there. Hit OK. And now it's linked. So at that point, this function block visualization, or sorry, this visualization is linked to this block right here. So, and we continue to do that. Now, in addition to the control area, which this one block here controls the movements, everything you want to do. Well, there are other blocks, and those blocks are explained again in this manual here. You know, this is the user manual that I downloaded with the thing, with the library. These blocks here are what they call FPC blocks, so Festo parameter channel blocks. So these blocks here are using this second 8 bytes of data in and out, both sides, to communicate various things to the controller. Basically, whatever you can do in here, like if I wanted to modify this to 120, for example, I could do that using the function blocks over here. I could just say, you know, PNU. I got to go into the user manual for the FHPP, figure out what that is, what that number is in the subindex for the PNU and subindex, and then I can read and write to it if it's available to do that. So I've now done that, and I come into here, again, I've linked my tag, my PLC. I'm going to dump this in because the old project is in there right now, the one that just has the bare bones. F5 to hit run. I'm just going to create the boot application. Okay, so we're online. Close all editors. Go to the HMI, and nothing's working. Something didn't work right here. Just one sec. I'm just going to do a clean all. Yep. And then a rebuild. And then a download. Say yes. Create boot. F5 to run it. What happened here? All the rest of them are working. I must have messed this up here. Hang on. Oh, I did file instead of control function block. So there, I showed you my first mistake. Change it there. Now we're online. Okay, so we're good. And I like to toggle a couple things on here. You'll see that this op mode, when you toggle over, it shows you that based on the number you put here, you're in different modes of operation. I'm only going to talk about direct position control today, so I'm already in mode 1. When you're in that mode, this right here is your velocity percentage. The velocity percentage is based upon what you have in your FCT project. So if you go to direct mode here, so this basis velocity, so this 2,500 millimeters, when you're programming, this 10 is 10% of 2,500 millimeters, so 250 millimeters per second. And the set value position, due to the factor group and the exponents that are being used, the 200,000 basically represents 200.00 millimeters. So first thing you do is enable the drive. You get a drive enabled, that's good. If you're online without having the checkbox, you're in monitor mode, so that's great. You can look at all this. I'm just gonna home it right now. Click on home, turn that off. Now it's homed. And I want it to do this move, so I'm just gonna say start task. And it should move to 200. So if I go back to here, go to operate, you'll see that the target's 200. There's my actual. My tuning's slightly off, 0.02 millimeters of error up and down a little bit. At least that's what you can see. If you're to trace the data, well, I won't talk about that. So now we've got movement. There's other things here. So in that same user manual, this user manual right here, you'll see that there is a picture that looks like this here. And it tells you that, hey, these FPC function blocks can be used with these certain Festo devices. And we're using this green one here, the EMCA-EC. And so what I've done is I've put each individual block in here. So there's an FPC diagnostics, there's an FPC diagnostics buffer, so on and so forth. So if I come into here and I type in execute, there's no errors right now. If I come over to here, let's see if I can create an error. So I'm going to go and I'm going to jog negative. Let's go jog negative, and it's moving. It'll go faster. Now we have a fault. See, we've got this fault indicator here. So what is the fault? If I come over to here, 18 is the message number, software limit negative. I go to my user here. There is the software limit negative. Additionally, I can do a read. It gives me this information here. Okay, so that's that. If I come down to here and go like this right now and try and execute this, it'll say, hey, listen, there's another FPC function block active. Well, basically, on these blocks over here, you can only execute one of these blocks at one time because they're all acting on the same information at the same time. So turn that off, turn this one off, turn this on, and now it works. And see this, it's populating the table here. Basically, it's populating the table with the exact same thing that you'll see right here, okay? Now, like I said, I can come over here, I can turn off the jog, I can reset the fault. Fault's now reset. Turn this off, come over here, and there's no message because the fault's been cleared. Fault's cleared over here, and fault's all good. Okay, so FBC diagnostics buffer, you can see how that works now. There is this FBC Direct MP. This is one of the more useful ones here. Again, on the Direct Mode tab, you have a base velocity and base accel. Theoretically, you have a decel as well. So this block right here acts on that. So if I don't do a write and just hit execute, it tells you, hey, it's 2,500 millimeters per second and 4 meters per second squared. That matches 25 and 4. Now I want to write, so I'm gonna reduce those to these values right here. It's now written that. Come back over here, and if I do a upload, see, this is now 2 and this is 3. And if I want to change it again back, come into here. So I write this, it's done. Come over to here, do an upload. Yes, and it changed it back. Okay, so you see that working now. And the next one here is MP file. Okay, I'm not going to do this, okay, but this is what this is for. So this FBC file and FBC file array, basically when you're finished configuring with the FCT software, if you want to take a snapshot or a mirror copy of what is in the controller and put it in your PLC for download later, that's what these are for. You basically come into here and you hit on execute over here and do an upload, or click on upload first and then execute, and it will suck up all the information. If you're on a CANopen network, that'll take about 2.5 minutes to do both, to do one way or the other, and the same thing. These are just two different ways. One's putting it in an array, one's putting it in a file. The file, the one up here, the FBC file, if you go to the device, go to files and do a refresh, you'll see that it's in this file right here. So I've already done this before. This is the size of it. So it's taking up space. And that's that. So I'm not going to do that because it takes about 2.5 minutes. I'm not going to waste the video time. And then this one right here is FBC PNU. If you download the FHPP manual, you'll see that there's, like I said, there's a PNU for every one of them. And you figure out what that is, you want to do with it, and you can read write to every parameter that exists. If it is right, you can at least read all of them. And then this last one here is a multi-PNU read and write, okay? And if you look at my variable list here, it's maybe easier to go offline real quick. Basically, I have 3 blocks for the FBC multi. I've got a write 1, a write 2, and a read. That is read, write 1, write 2, okay? And I'm referencing these tags right here and here and here. So when you're in the variable list, what I've said is, hey, I want to write. So if you go to the user manual for the FHPP, PNU 404 subindex 1 represents record target position. That'll be record target position number 1. And then the next one, it's index 2, 3, 4, 5, it keeps going. Let me just show you this real quick. So if I go to here, this is the user manual I was talking about, the FHPP manual. And you'll see that 404 is set point value, and record number 1 through 64 is what you're writing to. So I'm basically going to set the record table values, which are these right here. I'm going to be setting these values here up to position, well, 8, I guess. Yeah, up to 8. So go back online, and for now, I'm just going to execute. There's no error, so if I go to my read, FBC read, go to, where is it? This right here. This is the values right here. Okay, so it read the data, and as you can see right here, there's this one here to match to this one, and just keep going down the list here. Now, if I go to this here, I'm going to do a execute. This one here is writing data. So if I upload, see how I just changed all those, okay? So it's basically writing, and then if I do another execute and do the read, get it done, and now it reflects those values, okay? So it's basically the FBC multi is basically writing a bunch of PNUs all at once. And that's pretty much it. Yeah, I guess one point of frame is that, yeah, okay. So what I've done in addition is I've added some code so that I'm just going to cycle through some things here. So I just, I like structured text, so I just added some text to properly call the moves. So that's what all the structure and code is. It's not very difficult to follow. Basically, for a move, whenever you do a move, you want to set the relative or absolute. You set the velocity, which is the 0 to 100%. You do the position target. It's all explained in each one of these right here. I do the start task, which now starts the task. I wait for the acknowledge, turn off the start task, and wait for the motion complete. That's how every move works. Set a target, set a velocity, turn on the start task, wait for the acknowledgement, turn off the start task. You're in the middle of a move now. Now you wait for the motion complete, and then you're done. That's the gist of it. So on my HMI here, if I go back online, as soon as I turn this x-axis sequence on, I go like that, it's now executing code, moves 1 through 6. And the LEDs at the top here, just the top one just means that the step has been started. The bottom one means that it's motion complete. So it's basically going to continuously cycle through 6 steps, and away you go. Now that's it for my video today, and that's connecting a CECC-LK controller CANopen to a EMCA-CO controller, and that's it. Simple. Thank you, and have a great day.